Welcome back, Domo Nation, and happy Pi Day. To celebrate this wonderful holiday, and in collaboration with Mu Alpha Theta, I would like to show you all how to calculate the circumference of the Earth using nothing but a shadow, a protractor, and a little bit of math. But first, allow me to explain the history behind the mathematics of the problem. The problem dates back to ancient Greece in about 240 BC. A mathematician from Alexandria named Eratosthenes learned that the sun was directly overhead the city of Cyrene at noon on the summer solstice. Cyrene was only about 800 kilometers away from Alexandria. So, at noon on the summer solstice, Eratosthenes stuck a wooden stake in the ground and measured the degree of its shadow to be about 7.2 degrees, unlike the 0-degree shadow in Cyrene, where, because the sun was directly overhead, no vertical shadow was visible. Using this information alone, Eratosthenes was able to estimate the circumference of the Earth to within 1% error of its actual circumference, which is astounding given how long ago this was. In order to calculate the circumference of the Earth, we must first establish a few things. First, the wooden stakes set up in Cyrene and Alexandria were perpendicular with the surface of the Earth. What this basically means is that they each extend from the center of the Earth like this. We also know that each of the rays cast by the sun were parallel to each other, like this. We also know that the sun rays were parallel to the wooden stake in Cyrene because there was no shadow cast. What that means is that there was a 0-degree angle of the shadow. However, as Eratosthenes found, there was actually a 7.2-degree angle made by the shadow in Alexandria. Using the basic rules of geometry, we can find that because there was a 7.2-degree angle here, and because each of these lines are parallel to each other, there is also a 7.2-degree angle here. This angle actually represented the angle between Alexandria and Cyrene with respect to the Earth. Now we have enough information to set up the following proportion. We can say that the difference in degrees, or the difference in angle between Alexandria and Cyrene over the total degrees of the Earth equals the distance between the two cities over the total distance of the Earth, or the circumference of the Earth. We can rearrange this equation to solve for the circumference of the Earth like this. So, we know that the circumference of the Earth equals the distance between the two cities times the total degrees of the Earth over the difference in degrees between the two cities. We can actually fill in the following information. We know that the distance between these two cities right here is about equal to 800 kilometers. We also know that the total degrees of the Earth, like any circle, is 360 degrees. And finally, as Eratosthenes found and proved, the degree between the two cities right there is 7.2 degrees. Solving this, we can find that the total circumference of the Earth was approximated to be 40,000 kilometers. As a matter of fact, the total circumference of the Earth is about 40,300 kilometers. As we can see, Eratosthenes was very close. In fact, he was less than 1% away from the actual circumference. Now, let me show you how you can do this yourself. Now that we're outside, we need to find what angle a shadow makes at this time of day. In order to do this, we need to use a pillar or any object like this and line up the center of the protractor with the tip of that object. If we put it right in the path of the sun, we can find that the angle that the shadow makes is about 76 degrees. If you have a level like this, it can make your computation a little bit more accurate so that you know that your protractor, which is the reference point that you'll use to determine the angle, you can make sure that it's perpendicular with the earth, which you need to make an accurate assumption. However, using a level is not necessary. So, we still need to find where the sun is directly overhead. To do this, we can just simply look up the zenith, which is the position where the sun is directly above on Earth. If we go to timeanddate.com, we can find that Kiritimati is the closest location to the zenith. We will use this as our location. Now we can simply just look up the distance between Kiritimati and Latrobe. This turns out to be 8,856 kilometers. So, now that I have gathered my data, I can use the formula that we created earlier, which states that the circumference of the Earth equals the distance between our two cities times the total degrees in the Earth over the angle of our shadow. By substituting my values in, I can estimate that the circumference of the Earth equals 8,856 kilometers times 360 degrees all over 76 degrees. This comes out to equal 41,949 kilometers. So, while my estimate wasn't quite as close as Eratosthenes was to the actual circumference, I believe that you can do better. So, I challenge each and every one of you to go out, gather your protractors, and estimate the circumference of the Earth. Good luck, and happy Pi Day.